Hello, in this video, I'm going to give a walkthrough of my Collab 4, which is multimodal augmentation submission ready Collab. And since running the whole Collab consumes a lot of time, I have ran all the code cells and I do see them, they have ran successfully. So I would just give a walkthrough of it, but would not miss any code cell in this collab. As we have seen before, the process or the steps of how I have approached till I get the final summary is very similar to how I explained the previous three collabs. In these collabs, I'm going to taking that reference, I'm going to give a walkthrough and just add the points wherever it is required to make this collab understand better. Okay, let's start. Firstly, I import all the required libraries which will be required further in this notebook. Next, I would set seed 4, which fixes random seed, defines auto and plots the size. Next, I define compile and train, plot history I define, summarize run, and then I compare the results. So this first function compiles, trains and evaluates model. Then the second one trains and validates. The other one summarizes results and compares experiments. Next is text augmentation and classification. Here I load the IMDb data and decodes the reviews and cleans the text, and I then clean the text and define the text augmentation and create, train, validate and test splits and doubles training data with augmented text. So we can see the result of like original and augmented one. In the next one here, I create the text vectorization, defines a small text model and builds data sets, trains baseline and augmented models, plots and compares the result. So we can see here like how the plots are comparing the result of loss, like text baseline and metric, text augmented loss and metric. This is a quick table here. Next is time series augmentation and classification. Here in this cell, it downloads the UCI HAR data and keeps three working related classes, normalizes reshapes for conv1d, defines augmentation, splits train, valid or test, and creates augmented training data. This is the whole scene. We can see how it prepares. Next, I visualize original versus augmented train series. What I do is this cell plots one original and one augmented example for each of the three classes, which we can see here. Walking, original, augmented, walking upstairs and walking downstairs. Next is time series model, and here I define 1D model, create data sets and train baseline and augmented model plots and then compares. These are the plots to compare. Next is tabular data augmentation and classification. Here what it does is loads breast cancer data set, which then trains, valid or test split or standardizes using a training stats, defines tabular augmentation with noise and scaling, creates then augmented training dataset, which we can see in the output. Here I define a dense model with the dropouts, creates a dataset, trains baseline and augmented model, then plot and then compare. Here we can see tabular baseline loss and then metric, tabular augmented loss versus metric, and this is the table for reference. Next is speech augmentation and classification. Here what I do is I load speech commands, subset and create a waveform augmentation. Here I load the speech commands from TensorFlow dataset, keeps S no up fixes wavelength forms, waveform lengths, and then normalizes, augment speech with scaling, noise or splits shift, then splits data, creates augmented training set and plots the waveform, which we can see here. These are the waveforms that is created by this cell. Next is I define 1D CNN for speech, creates dataset and then trains the baseline and augmented model, plots, and then I compare the results, which is these are the graph to compare. Here, which loads the MNIST, normalizes, adds channel dimension, takes subsets, define document style, augmentation using rotation, zoom, and translation, contrast, creates the baseline, and augmented dataset shows augmented samples. We can see here these are the samples that are built. Next, this defines a small CNN, trains baseline, augmented model, and plots, and then compares. These are the plots to compare. Next, in the next video, I load CIFA R10, keeps 3 classes, forms a short video sequences of 5 frames, splits, trains, valid, test, defines frame-wise video augmentation with flip, rotation, noise, and brightness, and creates augmented training set, shows original versus augmented frames. These are the original frames, these are the augmented frames, which we can see here. Yeah, this cell defines a time distributed CNN followed by a temporal pooling and dense layer. Next cell creates a dataset, trains baseline and augmented video, models, plots, and then compares. Finally, this final cell collects the baseline, augmented test matrix for text, time series, tabular, speech, document, and then video. I would next plot baseline versus augmented metrics and plot improved bar chart. So overall in this notebook shows the augmentation is not limited to standard images. I applied augmentation to text, time series, tabular data, speech, document style, image, and video, then compared baseline and augmented model to study how augmentation affects generalization across modalities. Thank you. That's it for this notebook.